So welcome everybody to this webinar set up by me, Matthias.
Patrick.
Jesper.
Nice colleagues. So let's move on to some fun facts before we get into it. There is a hacker attack happening every 39 seconds. So that's a good fact for you to know. Cybercrime is more profitable today than the global illegal drug trade. And if you do remember the incident with the open source tool Log4j, there was, according to Checkpoint, 72 hours post the outbreak, 830,000 attacks was logged globally. That is according to Checkpoint, though. According to Qualys, more than 2,800 applications that they were scanning had data collections from. They also concluded that it took, on average, 17 days to remediate the issue. And why I'm mentioning Log4j is because we're actually going to talk a bit about open source tools. So a bit more about who we are. We're the Kestit Pentest team. 8 people. And aside from us beautiful here, we have Jess, we have Yoon, Oron, Andreas, and Drake. Fantastic bunch of guys. Quick little side note, you can always Google Drake. He's a nice fellow. There's some good pictures. In total, the team, we have, I think I counted this yesterday, and it was approximately 70 years of work experience. So we turned 70 this year, which is fantastic. We should actually grab a beer for it because somewhere it's Saturday right now. So, hey. Also, what we've collectively been doing for the past 70 years, I would say would be focusing mostly on web applications. Around 80 to 90% of our assignments are focused on that. Our sectors that we've been working within are retail, industry, manufacturing industry, bank and finance, healthcare, and government. When it comes to retail, a lot of it has been focused towards PCI DSS demands. When it comes to the manufacturing industry, a lot of it has been with PLC systems and SCADA systems. But yeah, going back to the grounds, like 80 to 90% is focused on web applications, APIs, and surrounding infrastructure. So for today's agenda, we're going to have some fun and discuss how to bring security into your development process. We're actually going to look at some nice slides about how you work that into the SDLC. In between the next part that we said we were going to do, we have a little Easter egg, an intermediate surprise for you all. And who doesn't like a surprise? So let's have a good time looking at that. After that, the fun part begins. That's when we're going to look at some war stories, and who doesn't appreciate to listen to a war story from people who didn't do military service, or at least I didn't. Did you do military?
No, I didn't.
No. So none of us did. But war story in this case is mostly just focused on hacking, right? So it's just a cool name for it. We could say hacking stories as well, I suppose. But yeah, did not do military service. Open source, we're going to discuss the benefits and the downsides to it. The downsides would be something like Log4j, I would say. Let's jump right into security in your process. So let's look at the software development lifecycle, but instead add the little twist to it. We will add secure in the beginning. So it's the SSDLC, all right? And where you start in that part is actually with the requirements, as you said yesterday.
Yeah.
Correct. We're idiots. So in phase 1, this is normally when you sit with the stakeholders and you involve the developers, but you also involve the security consultants or the security team at your company, if you have one. And you set up the functional requirements together. Then you step over into the part which is called the design phase. This is where we get more involved with the threat modeling. I'd say that as a typical example for this instance would be if you were to write up a functional test in this regard and say, if a user accesses the admin portal, he or she should be able to see all the users, the information about that user, etc. And information security demand in that case, or functional demand, would be that there should be nothing to see unless there is a valid session token added to it. If there isn't a valid session token, you should just get redirected to a login page. So that's where we differ. You could see it as a functional test. It goes into the narrow test case of saying this should happen, and then the security guys goes in and says, well, all of these things shouldn't happen. We're not pessimistic. We're just a bit annoying. Development phase. So typically in the normal instance, this is when you just start working on that little demo you had initially and keep writing on that code instead of throwing it out. I'd say involved with the SSDLC, you'd add some nice tools to it. In this case, a static code analysis tool. You can also add a CSA tool, and both these tools are fantastic. The one for static code analysis will basically tell you where you've done something incorrectly with your code and just tell you how to fix it. And with the CSA tool, it helps you identify if you have open source tools that have become too old, needs to be updated, if there's vulnerabilities to it. So that's why it would be good to involve that into your pipeline. I'd say that fantastic tool in that instance, not a partner, is Snyk, or Sync, as a colleague calls it, probably to piss me off. Phase 4, verification phase. So this is typically where you would end up going into the last part of it. You get the security guys involved and ask them to come in and do a bunch of testing. But instead, we turn it around, and this is when we would normally come in and help you do a code review, a manual code review, and see if we can find something that differs. And then, well, typically, I don't think you can skip it. We would come in with the deployment phase and do the penetration test. But as this is an ongoing cycle, this will never end for you. That's part of the fun. So after you've done that last part with the deployment, you're stepping into the maintenance and evolution of the application. So this is just an ongoing part. So then you go back into the risk assessment because business wants new features added to it, and you want to make sure that they work properly. You don't want to add bugs to it or security issues. So then you just go around the wheel, be the mouse. What also could happen when you are in the maintenance phase, because even if you do this type of work, there is no guarantee that you will always be safe. That's not how it works. You can always have 0 days present itself, especially when it comes to open source tools. And worst case scenario, when you find one of those things, you actually have to rewrite a lot of the code. So yeah, and that's actually a good thing, I'd say. I'd say when we look at, because we're a European company now, when you look at how it traditionally is in Europe, I'd say that you are not as involved with the SSDLC. But when you look at Scandinavia, we're much more focused on shifting left and going towards security. In some cases, you even find companies which have one security personnel added to a project constantly, which we find fantastic. I understand that that's a budgeting issue, but for us as consultants, we actually see a little hike in what we get as assignments. So we're much more involved nowadays with threat modeling coming into a project, even if it's late into a project, but preferably in the beginning, helping them identifying risks when they're building their application. We're also more involved when it comes to applying scanners and tools. So we have clients coming to us and asking us to help them setting up a SAS tool, a DAS tool, or CSA tool, making sure that we remove all the false positives from that tool and that they get the data that they actually need. So it's nice to see that we're getting more involved in the entire development phase, because that just gives them more gains and less headache. Same thing with code reviews, also more common, and of course penetration testing, but that's what we do. So as I said initially, does it get these products to get out of vulnerabilities? And are they 100% like guaranteed to be protected? But of course, they're not. Why do you pay for a product like this, or for a consultant to come in, or personnel to help you? Well, it's the same reason that you might buy a Volvo. You purchase the Volvo for a worst case scenario. Like if you were to happen to be in an accident, you dampen the risk of having casualties. At least that's what Volvo tells you. That's why I drove a Volvo, at least. But that's why you do have us involved, to dampen the risk, and also proving that you're actually trying to do something about it. And if you dampen the risk, instead of having the entire user database getting leaked, maybe you just had a brute forcing attempt to the application, or someone managed to get credentials to a low privileged user but didn't get further than that. So you dampen it. That's why. Since we're looking at this, if you have any questions about it, you can just fire away. There's a Q&A. We'll take all the questions in the end, because we want to focus on the presentation. And if we have questions that we don't manage to answer during the presentation or during this hour, we'll email it to you afterwards. So yeah, before the war stories from the guys who never did military service, let's get into the nice little Easter egg, which is processes. Woo! Nobody gets fired away by processes. But anyway, so how would the pen test process typically look for us? Just so you get an understanding of where we started before these war stories commence, right? Well, we would start with a startup meeting. This is where we sit down with the client, listen to their issues and what they consider to be part of the scope. We also add our input to it and see if they missed something that should be added, or if they are just being negligent, to be honest. We ensure that we get the test accounts and all the information that we need. Next part is the legal documentation. That is super important for both parties. If we don't have that, it could eventually become a crime. So we don't want that. This is where we write down everything that was stated during the meeting, what we agreed upon, and we send a statement of work to you guys, and you just approve it. It's a proposal and an NDA as well, because you don't want us to talk about you, and we don't want you to talk about us. Unless it's a good thing, then we want you to talk about us. The engagement life cycle. So this is the actual penetration test, and next slide will actually show you more about that. And that always ends with the report and debriefing, and that's also part of the next slide. So let's just skip to that. So the penetration testing methodology. It starts out with the information gathering. Aside from having the startup meeting, hopefully we can have at the start of the test, it would be nice to sit down with the client again and get some walkthrough of the application, because the more information the tester could get, the less she has to spend to understand it. But that's not the biggest part of the information gathering. That would also be using tools that are non-evasive. It could be evasive as well, but just information that is freely available on the internet to understand as much as possible about the company. It could also be tools that help you understand the network topology, if it's an internal network test, understanding the operating systems of the infrastructure, and so on. There is also a bit cooler name to it. It's called reconnaissance, but it's basically information gathering. Stepping into the next one, that would be vulnerability analysis. This is where we use tools as well. Sounds like we just use tools. We don't. We're actually competent people. So we use, typically we use tools for infrastructure scanning. That would be Nessus. Nmap is also one tool that we use. We also have a web application scanner that we would use in those instances that we were testing a web app. Why are we using these tools? Well, it's actually to be more cost effective towards you guys as a client, because normally the findings that we find from these tools, those are the low hanging fruit. We would find them anyway if we tested it manually, but instead of us spending 2 to 3 days just doing that and hashing that out. We use those tools to just simplify the process and focus on what's most important. That's the manual testing. So that would be exploitation. Oh, what a quinkadink. So once we have identified vulnerabilities on your platform, infrastructure, or whatever it is, we could take information that we might find from the vulnerability analysis, for instance, and connect some pieces into a nice little chain, attack chain, and then that together might be a good thing for us to use and then manage to attack you guys. That's when you enter the post-exploitation phase. So let's say Jesper here, he performs a test, it's infrastructural, he manages to get access to a server. And when he's on this server, his next assignment is to identify how critical that server might be. What information might be on it? Is there any personal information? Is there credit card data? Does it give him a potential to do some privilege escalation on that server? Can he make some lateral movement from that server to another? That sort of thing is what happens in the post-exploitation phase. Always last is the reporting phase. I wouldn't say that it's necessarily last, because what we typically do is in the beginning of the assignment, you do generate the report and then you add to it as you go. So for each finding that you have, typically what I do at the end of the day, I just add to it so I don't forget to add it later, and make sure that that is part of the report. What is entailed in the report is typically a summary of the findings, an executive summary where we just write down everything that we found and potential consequences from it, but on a more C-level type of text, you know, so that they understand it. It's not technical mumbo jumbo, because that's not of interest for business. We also add to it the more detailed description of every finding, where you have the abstract, the specifics, how to solve it and remediate the issue, and what affected systems have that issue. So that's more for the IT people, or in case of an application, it's more for the developers. That's what they want to look at and make sure that they can fix the issue. And at the end of that report, we send it to the client, and we also make sure that we have a follow-up meeting. And if the client has any more questions, they can always email and we'll help them. We're more than happy to help. So let's move over to a war story to someone who did not do military service.
Yeah, I did not do any military service, but I've been in a lot of wars, to say the least. The story that I'm going to present is a story that I call the phone incident. So the backstory of this story is one day I was working at a security firm in Sweden, and I was called in by the sales guy and asked me to basically take a phone call with a client of ours. And the phone call, they mentioned that they had an incident in their B2B system and they wanted help, basically. So the phone call resulted in us taking a forensic investigation to help them out, but also do a full penetration test of the B2B shop and corresponding administrative interfaces, including a source code analysis. So the pen test outcome, we found a lot of different vulnerabilities. I'm going to highlight the ones that's applicable to this story, I believe. We found a lot of broken access control. And access control in a web application is basically you enforce authorization on functionality that you don't want normal users to access. In this case, we found, for instance, like it was possible to add permission for any user in the administrative interface. So if you had access to the administrative interface, you could basically just enumerate indirect object reference, which is also a finding in itself. And that is using incrementable IDs, for instance. So in this case, the permissions was a list of integers from 0 to 18, where 0 was the system administrator role. So any user in the administrative interface could basically elevate themselves to system administrator without any problem. We also found SQL injections, and and that was based on stacked queries in the administrative interface as well. And the benefit of having stacked queries is basically that you can inject code to terminate the existing SQL query and basically perform any type of statement or anything, which is a benefit from a pen testing perspective, because we could basically do anything to a table. On the contrary, if you're having let's say a union SQL injection, the only thing you can do is basically add a different select statement, and then you have to rely on the amount of columns, for instance, that you would receive from the previous one, which could be hard sometimes. And in the web shop as well, we found Boolean-based blind SQL injection. And that type of SQL injection could be quite trivial in some cases, but it takes a long time because you basically enumerate the characters from the database. So what you do is you inject like is true or false to the query to see the result of the output. So if you get one type of output, based on if it's false, you could immediately determine if the query that you added was true or false, and systematically enumerate the characters. The administrative interfaces, or the interface, was accessible going to the admin path. It didn't enforce any MFAs or multi-factor authentication on the users, which in itself is a pretty big finding depending on what you find when you come in. And I'm also going to come back to that as well. There was when brute forcing accounts, one of the things that we try to prevent, or that we don't want to do, is starting to lock accounts out. In this test specifically, there wasn't any lockout policy, so anyone could basically brute force any account to eternity, basically, without even locking an account out, and it didn't even have any logging to verify if an attack like that would even occur. And based on the SQL injection, we were able to dump the entire user database as well, including the hashes, which in itself are SHA 512 hashes. And in a normal engagement, when we do get access to those hashes, the immediate thing that we do is trying to crack them using either password list or using brute force techniques. So the thing that we need to know there is, how does the password policy look like? Well, for this client specifically, the password policy was at least 4 characters. So with the current setup that we have, we were able to do 3.4 billion hashes per second. So we managed to crack the majority of the password within an hour at least. And as I said, with the data logging, they didn't have any data logging outside of the standard access logs and error logs at all, which in itself is good to know for this story as well, because I will come to that later. Some other findings as well. Considering it's a B2B application, a standard feature in those types of application is being able to impersonate the user. And the reason for that is basically for a representative to view the experience of an existing user in case they are having any problem with placing an order, for instance. But we also found a lot of leaked passwords and email addresses applicable to that specific client in various types of leaked databases. And we'll talk a bit about this outcome as well. One of the I think the simplest answer to this, or why we found these types of vulnerabilities, is that it was a third-party e-commerce system that the client had bought. The e-commerce system in itself had been under development and usage for the past 10 years at that time. And the thing is, it's been modernized over time as well. And the issue with that specifically is that there hadn't been any refactoring of the code. And that meaning like removing old functionality and also restructuring the code to ensure that all parts are replaced with more secure code, for instance. And the vendor had also done a lot of specific custom work for our client specifically to add functionality that they needed. And a lot of those functionality were not even documented. It was basically one developer adding one thing Nothing got documented at all. And one of the worst part as well, considering that it was developed over 10 years, there's been a lot of different developers taking lead on the application, and some of them didn't even work with the vendor anymore. Coming back to the forensic analysis, I think it's worth highlighting as well that the full details of this attack will probably never be known other by the ones carrying out the attack. It could have been, it could have been a sophisticated group of people that have been targeting the application and then using the application for at least a while to monitor the processes and how everything works, looking up accounts, who is authorized to do what. And there's also an overhanging risk that this was entirely an insider job as well. We don't. But we do have some events that we know for certainty. And that is that someone had managed to gain access to administrative interface. Based on the collected logs that we had, someone had been using the app for at least 3 months. And why am I saying 3 months? Yes, because they only had log retention that collected the logs for 3 months, nothing more. Everything else was discarded. And I could say to some honesty that someone had been studying the application and the entire order process from placing the order to its fulfillment. Either that or someone that actually knew the application and how it worked. We could also say with high certainty that customer details have been added, that including shipping details, company details, and an increased credit limit. The order that had been placed had also been approved according to all processes using the authorized accounts that normally would approve those. It had been added to the tracking system. The products had been reserved and the product had been shipped. So coming back to the incident again, when I was speaking with the client on the phone, they told me basically that they made a huge financial impact on themselves. And the attackers, well, they got away with a couple of iPhones, and not one iPhone, and not only one pallet of iPhones, but merely 19 pallets of iPhones.
Which is quite a lot.
And I think the plot twist to this entire incident was that our client wasn't the only one using this e-commerce system. Thank me.
Nice. Thank you, Patrick, for that.
Thank you.
And now I'm up, actually. As previously mentioned, Patrick's war story was based on an actual incident. My story will be more of a casual penetration test that actually leads to something more serious than that. So the actual backstory to the test is a very simple scope from a fairly large client with a fairly large scope of exposed services and web applications. So the test itself was conducted in a very standardized manner. There was the initial reconnaissance, and what transpired for the testers was that the more they looked at the resources and exposed web applications, it kind of quickly showed that they actually had a pretty good security posture of their exposed services. And they did not expect this with that amount of resources actually exposed to the public domain. When we usually do tests with publicly exposed resources and applications, we normally find a lot of things. But at some point, as the project progressed, they actually found a web application that showed that showed symptoms of having more issues than what they had seen on the other web applications they tested this far. they sort of focused their efforts on this single web application, which turned out to be a order and ticketing system portal. So it was used to actually add tickets within the company or order specific resources or material. So several critical vulnerabilities was found. It was discovered quite quickly while testing the application that one specific function of the application was used to change password of other users. This specific function was, however, protected by the administrative role in the actual portal. When they started to test using this function, it was quite fast to see that the actual function used the information taken from the Active Directory of the user using that function. And it was discovered that in a manner of changing the organizational units in the information of the user, you could change that specific string to the administrative organizational unit, and that made the application think that your user was based off the administrative group, which allowed you to actually get access to this function. So they were able to change passwords of users using this function and modifying the actual rights of the user using the function. Now, this could be well implemented in the case that users were hard to actually find, but they weren't. All of the users registered for the portal actually had an incremental ID to their actual user. So let's say the first user created in the portal had the user ID 0. The next one created would have the user ID 1. So being incremental like that, it's very easy to enumerate the amount of users and in what row users are. So using this change password functionality, we could roll through each and every user in the actual scope of users using the portal. This allowed us to actually test take over accounts using this method. And this specific vulnerability was a LDAPing integration that used LDAP for authentication to the actual function of the site. So that's one of the 3 vulnerabilities I'm going to showcase here. The other one would be a broken access control, much like the one that Patrick showed earlier. This was found in the ticketing system saving tickets. So they used an SQL server to actually host all of the ticket data, and it was discovered that you weren't required to have an authenticated session to actually make queries to the SQL database. So we basically could fetch any data from that database as we like. The third one and last one is actually the RD web service that was running in this environment. And together with the first one, the LDAP injection, we could actually fetch accounts and use those accounts to actually gain access to that RD web service running. So the actual kill chain of this would naturally be abusing the admin role and use the functions to take over accounts and actually gain entrance to their inner networks by using remote desktop. So that's a bit of an oopsie. Conclusion of the test would actually be, in hindsight, that this could have been prevented quite easily. Running security in your SS TLC. A part of this is also what we expect of developers today. So being a developer, you actually have some sort of a responsibility for the code you write and the frameworks and libraries that you use. So we need more competence within developers to actually be more security minded when they develop new code. And that should be a part of our SSDLC. Definitely. So that's my short story. So I'm gonna call on Matthias.
All right, my time again. Hope you didn't get bored of hearing me before, because now you're gonna listen to me again. All right, so backstory. Is there backstory? Yeah, it was a classic allmän upphandling, the RFP. So municipality in Sweden, they wanted a vacation portal where their employees reported if they wanted to have vacation or not, which they preferably do. And they just got the cheapest product there was, which is typically the process for an RFP. A little later, they noticed that there was some issues with it. Hence, my colleague Yoon and me, we arrived to the place and we did a small little threat modeling session pro bono for them. Just helped them to figure out some issues what they could do better. But since this was a third-party application, it's not entirely up to the municipality, right? So they came back to the third-party owner and asked him for help, and well, they basically said, we're not going to do a pen test. So they had to pay for it themselves. So the actual test, which we got to do in the end, it was just a typical web application written in PHP with a web server added to it. And I'd say that, you know, when it comes to the test, I was off to a pretty great start when I just tried out a simple thing. So I'll get into that in the pen test outcome. I'll mention 3 pointers, but that's all, because it's a long time since I did this test, and I can barely remember my own age. So I'm pretty impressed that I can remember three things from this test, let alone remember my daughter's age. I just get by calling them the big one. And if you guess this correctly, you're awesome. But the little brat that just continues to ruin everything and trashes the house. That's the name for the little one. But yeah, so password complexity. I registered a new user for the application, and I tried to just append one character, a simple small character A. It worked. So not security in mind there, I'd say. That was in the report. I moved forward to going into the profile part of that. And what I found there was that you could upload your picture, which I did, but not really though. So what I did was uploading a PHP file with a web shell script to it. And what I managed to do through that, with some nice magic and file inclusion vulnerability added to it, I managed to get it running through the URL. So what I had now was more or less a CMD communicating with the web server through my browser. And through that, I managed to dig out a bunch of stuff. Not only was the municipality the only client using this web server, I could also identify many others. Also known as a bad thing to do. Not from my side, from their side. So in the end, or not in the end, the last thing I'll go through was that I found stored cross-site scripting. I managed to inject some script to it. And what happened was that I managed to send my vacation booking to my boss. And in that, I added a script where I wanted to grab his session cookies and her, but it was me who was the boss. And when I was the boss logged into the application, I went in to approve it or just have a look at it. It grabbed my session cookies, and the low level user could all of a sudden use that session cookie to approve their own vacation. So that's what I did. Also known as poor session management. So yeah, that's just in short what I did with my test. Did I get my vacation? No, I did not, because it was a test. What happened in the end? Well, I handed over the report to the municipality. There was a bunch of issues to it. They went back to the third-party owner. They thanked them for the report, but they didn't see much of an uptick when it comes to taking care of security because they were already paid for it. And that's the typical way of working when it comes to some certain third-party applications, I'm sorry to say. So yeah, that was my test a long time ago. Let's step into the open source part. We're going to talk more specifically about the ups and the downs, and the one who's going to talk about this is my fellow Jesper.
Hey, so looking at these war stories, it's at least clear to me that some of these had some open source projects running, and they weren't specifically the issues, although they could have been. But we're actually going to talk about some of the ups and downs of using open source. So the obvious one on the positive side is the actual cost. There's little to none upfront costs to these open source projects. It might be that you have to pay some sort of support or have some kind of support company help you out with the actual software itself. For example, like I think Red Hat, it's still open source. You can download it, install it, but if you have any issues with it or need some professionals with it, you actually need to pay up. So that's a good one, I go. Most of these projects are also very well established. They've been around for quite some time. There's lots of people helping out, and they're basically well established. Easy transition as well if you're multiple developers in a project or something in-house developed. It's more often easier for these developers to actually get a hold of the project or the code if it's using well-known open source tools or projects. And the community, of course. What developer hasn't used something like Git, for example, where you have community projects and lots of people working towards making it better and developing it? So that's a big plus, naturally. Lifecycle actually is actually on both of these slides as a good one and a bad one, because a lifecycle can be very good with open source depending on how big it is, how well used it is, how well established it is. Normally the bigger ones that are more commonly used tend to live long because there's a lot of people helping out with the actual projects. So then we'll go over to the actual downs, which is possibly maintenance. A lot of projects, open source projects, actually have very good maintenance if it's widely used, but there are those projects that are not typically mainly used, but used in a sense of being there. Some people recommend it, some people don't. They're there, and if it's not a big project, you won't have very much maintenance about it, actually.
There's what could be added is, if you look at it from a develop project from a business, right, and they use a lot of the open source tools, there's also maintenance on that side. So that project needs to make sure that they update the open source tools that they use. They need to make sure that they're not proprietary tech and they're vulnerable.
Yeah, absolutely.
So that's high maintenance as well.
Absolutely. Thank you very much, Matthias. Another big issue is actually licensing. If you make any product that you're hopefully about to sell, or a service you're selling, you will actually be quite competent when it comes to the licensing of open source software, and it's an issue you have to deal with if you tend to sell your products. And naturally, security testing, here it goes. This is not a big thing on open source projects. There are some community efforts naturally to actually test test the different kind of code and the actual software of the project. But it's lacking, definitely. Definitely lacking. And vulnerability exposure, naturally, that goes hand in hand with security testing, more or less. You have the actual vulnerability exposed when using the open source software. If it's not a well-established project, big project, those have them as well. But it's more, you'll run into more vulnerabilities with not so big or well-established projects that are open sourced. So that's a big issue. And naturally the life cycle. If it's not a well-established and maintained project, you might not have a very good life cycle of that particular project. And that's going to be an issue for you if you have a product or internal software used that uses this specific project or this specific open source code, and it doesn't get maintained. You will not get updates, and vulnerabilities tend to come along as time goes by. We still see 0 days on old software coming that can be like 20 years old. So yes.
All right.
That's it.
So what have we learned today? Well, you should definitely drive a Volvo because that dampens security. Penetration testing is good. Security is good. The SSDLC is really good.
It is. Yeah.
We
definitely.
do like to talk about war stories, even though we did not do any military service. And now we're going to do some Q&A. So let's have a look at some questions. This is actually from our previous intern, which is lovely to see. Hi, Ksenia. What advice would you give to a system backend developer when it comes to writing more secure applications in conditions when there is no security specialist in a team? What are the most common errors that you may have? Well, you know what? We'll do the first one first, right?
Yeah.
So typically what you could do, which is fairly low cost, is invest in something like the tool SNCC. A SAS tool, so static analysis. It will look at your code and assist you with how you are to develop it. There's always OWASP as well. Open web application security testing. Yeah, right. And that's where you can go to get some cheat sheets or help with when it comes to secure coding practices.
I think the benefit of having SNCC as well, like an example, there is a lot of products doing the same thing. But the benefits of having SNCC, because they have a free version, I mean, that could be a problem if running it in an enterprise environment. But starting to learn security could be good because it integrates into your IDE and gives you recommendations and ways to fix the code directly while writing as well. And now with the evolving things like Copilot, for instance,
Right.
where you have the benefit of having at least some secure coding practices and getting help. And I mean, if you're starting to use a secure framework, Copilot, for instance, will look at that code and give you references to how that code looked in different classes, for instance. So that is one advice.
I'm thinking there's so many levels to the answer to this. So
Yeah.
we'll actually email out a full description on Copilot. We'll have OWASP, and we'll add SNCC to it.
Yeah, I have some recommendations as well. So yeah, let's add it.
Yeah, so one of the follow-up questions was, what are the most useful testing tools, which is kind of what we came into there. What are the most common errors that may appear in the code? Well, I'd say that OWASP Top 10 is a good guide on what is some of the most common issues that we find.
Absolutely. From a personal perspective, one of the few that I actually typically see is validation of data in general.
Yeah.
That's a big issue, definitely.
Oh shit. How you doing, Danute? That's nice to see you. Hey, so SonarQube versus Veracode, which one do you like? I wouldn't say that I've actually only used SonarQube, so I'm gonna have to go with that one.
Same here.
But if you've used Veracode, like get back to us. Is that good?
It's probably just as good.
Yeah. No, it's not.
That's not-
Let's see here. We have a question. Isn't it sometimes the case though with open source software that wait, okay. Isn't it sometimes the case though with open source software that oftentimes because of the nature of the visibility of the source code that vulnerabilities are patched quickly in the case of a well-maintained open source repo?
Yeah, definitely. But that's the back again to well-established community and maintenance. If you have a big projects that are widely used, let's take Apache for example. I mean, that's a fun one, right?
Yep.
Talking Log4j as well. Ordinarily, they would be considered secure because they have so much people helping out in community and people helping out with security in general, right? And it's widely used, and so you get coverage on a completely different level than in less used projects. So yeah. I would definitely say that the big open source projects are good projects. Yeah, for sure.
In general.
In general,
But
absolutely.
it's not like Apache has never had a critical.
No.
It's
And that's what I mean as well.
Yeah.
Even if you have a lot of people looking at these projects and helping out with security, you are still gonna find issues. You're still gonna find security flaws in the years to come as well.
yeah. I
Just
mean,
like,
you have threat actors out there that also can look at that source code and
Yes.
abuse it as well.
Yes.
Right. So that's more or less just an open-end library telling you this is how we built this, and they can abuse that.
yes.
Um,
So let's go for the next one in this chat.
take on.
This one.
Yeah.
Philip, hello. Hi guys. I wonder what would you recommend for someone who works as a developer but want to learn computer security? Where do I
Ooh.
start to learn? That's a hard one because
It depends.
yeah, sure, it depends. I did that journey a couple of years back, and it can be confusing and hard if you haven't taken part of the actual scene of security, for sure. I would like to actually give a lot bigger answer than I'd feel comfortable giving right now.
Yeah, but I mean,
So-
short answer that depends. Like if you want to become blue teaming, work with network infrastructure like CompTIA,
Yes.
application network
First of all, you
security.
need to narrow it down
Yeah,
to exactly what kind of techniques
Exactly.
and areas you want to actually cover.
or if you want to work with something like we do, I'd say Hack-the-Box is useless. What's the other one? What's the TryHackMe.
TryHackMe.
TryHackMe is a perfect place to learn penetration testing.
You have a lot of information on PortSwigger, which are the
Yeah.
company that makes Burp Suite.
Yeah, you have
we
Burp
use
Suite
a lot.
Academy. Yeah,
Burp Suite Academy, you have HackerOne, for example. They got a lot of tutorials and information on security in general. So there's a lot of places you can actually go if you're curious about it.
yeah.
I would say as well, the OWASP community is a really great resource
Yeah.
when it comes to finding information and resources of how to develop secure code when it comes to web applications specifically, or
Yeah.
mobile apps for that matter. And all of their list contains like they have references to code that's being used in some sense on where it's insecure, and how to think in input validation, how to think in sanitation, how to think in to prevent SQL injection, how to prevent or how to design access controls, for instance. So I would say from my perspective, that is one of the best resources available.
For sure. And one, so Philip, what you could do is connect to either one of us on LinkedIn, just say hi and tell us what you specifically want to go into what field, and we can see if we can help you out there.
Yeah, sure.
Right.
This is a
I don't-
very interesting
I
question.
don't know if we have time to like. We can do a quick one, maybe.
Can we do like squeeze in this one?
Yeah.
This is actually quite interesting. How common are the risks with social engineering attacks in the corporate domain versus the private domain?
Squeeze
And
one.
how do you mitigate those risks?
Well, it's like a
Squeeze it in,
30-minute lecture here.
That's
Sure.
Yeah, that's a long one.
You have 2 minutes.
Yeah.
Go.
It's an actual threat, I'd say. It's a serious threat for sure, and it does exist to a big extent. Even if people think of it as something imaginary, James Bond like behavior. It's not. It's quite simple and widely used, definitely.
I mean,
Privately as well. I've had personally several contacts try to add me to my LinkedIn network, and which were obvious fake profiles. Where they're from, I don't know. But I mean, if they wanna stake out my network, based on what I work with and stuff like that, that's a serious thing. And it's
but you also want
reality.
your password in one of those, like.
Fair.
No, but I mean, it could be as simple as an attacker just calling up IT support for a company, asking them to reset the password. A simple thing like that could have tremendous effects,
Yeah.
depending on the accounts, of course.
But in short, to mitigate it, like education.
Yeah, education and awareness.
education personnel, and you need to do it like quarterly. It's not enough to do it once a year because you forget it.
Yeah.
Right?
And social engineering specifically would be targeted mostly corporate domain, I'd say. Definitely, yeah.
So I think we're actually running out of time. It's 11 o'clock. So if people want to go for lunch or enjoy the last hour before you go on lunch break, then thank you for joining us.
Yes.
Hope you got some good information from this. We'll reply all the questions, send it out in an email for you.
Yes.
Also nice to see you, Danute. Nice to see you, Ksenia. Right.
Thank you.
Thank you so much.